we have Todao. We have Avishai. Avishai is going to be presenting Scylla. And welcome, Avishai.
Hey, welcome.
We can now hear you, and you are live.
Hi.
Hello.
What's up? How's life?
It's pretty good. How's yours?
Good.
How was the
Also
keynote?
pretty good.
Did you get a lot of interesting questions?
I got a few. It's always great to have questions. Although in normal conferences, people buy you booze, to get answers. So that's kind of a bummer.
Yeah. I think no one is more happy with this sort of arrangement, but we make do. So without further ado, please, your presentation is here and the stage is yours.
Thank you. So my name is Avishai. Shalom. I'm a developer advocate at Scylla DB. Scylla is the fast, scalable, and boring database. So of course, when you hear about the new database, everyone's like, great, like why are you writing another database? There's so many databases out there. Haven't the Jewish people suffered enough? And the obvious answer is no, Jewish people haven't suffered enough. It's a known hobby of the Jewish people to suffer. If you're an Ashkenazi Jew, you know exactly what I'm talking about. But we actually have pretty good reasons why we wrote another database. There's been a lot of new and great ideas, especially in the NoSQL and the new SQL community around the last 10 to 15 years. But it turns out that scalability and availability are still very, very hard problems, and for very good reasons. Because of the CAP theorem, we all know it's not possible to write a database that's consistent, highly available, scalable and partition tolerant all at the same time. So it's still a hard problem. There's a lot of research and ongoing work on this. But not only that, database maintenance is still very, very hard. If you're running a database in production, you've suffered, you know exactly what I'm talking about. But the hardware and the operational environment that we are using databases in have changed a lot in the last 20, 30 years. We now have the cloud. We're running in an environment that's much more dynamic and scalable. We are using much more data than ever before, and uptime has become much more important. 10 years ago, you could take a system offline for maintenance. It's not really an option nowadays. You need really high availability and all of that. So we need new designs for new databases that actually deal with those challenges. And especially, performance and actually utilizing the hardware. It's not very uncommon to see applications and databases that are running like 50% utilization of servers and can't actually take advantage of all the hardware that you're paying for in the cloud. So Scylla is a database that's extremely fast. What do I mean by extremely fast? It's not uncommon to see Scylla servers doing over 1 million queries per second, sometimes a lot more on a single node, not even in a cluster. And it's great that you can actually utilize the hardware that you're paying for. And we are doing this in very, very low latency. It's not, again, not uncommon to see a single-digit millisecond latency, depending on the hardware, sometimes even less than 1 millisecond. And that makes your application servers work much better because they don't have to wait for the database. If you look at systems, you often see that you have many threads that all they do is just wait for the database. And Scylla has predictable performance. It has a very, very nice latency curve, even on very high percentiles, which is very important because at the end of the day, the high percentiles actually correlate with user experience. So if you have flat the distribution of latency, that means happy users and usually better business results. Scylla is also very, very scalable. It's not only scalable as in adding more nodes and vertically scalable, scaling, it's also horizontally scalable, meaning that you can actually use bigger and bigger nodes. This is a very common limitation for most databases, that you cannot grow and to use very large nodes because of a lot of problems with multi-threaded architectures that don't allow you to use all the CPUs and disks that you have. Scylla doesn't actually have those problems. We have linear scaling in CPU, and you can use very large machines. Which is great because then you don't actually have to deal with the operational burden of very large clusters. Sometimes we see clients that move from Cassandra clusters that are like 100 machines or 300 or 30 machines, to clusters that are like 5 Scylla machines or 3 Scylla machines, very, very small clusters relative to other databases. So that's great. You don't need to work that hard. And how do we do this? Scylla has what we call a symmetric architecture, where we basically shard and replicate data across nodes. This is done automatically by Scylla. Scylla is taking care of all of this. And it's also active-active, meaning that you can actually read and write from all the nodes simultaneously. There's no limitation about that. You can also do what is called a geographic replication, where you have different clusters that might be running across different parts of the world. And Scylla allows you to use both clusters, or 3 or 4, or how many clusters you want simultaneously. It's all active-active. It's also very good for resilience, because you know the cluster you're failing over to is actually working and operational because you're using it all the time. On the node level, we have a microarchitecture, so to speak, where it's known as a shard per core architecture. There's a framework that is called Scylla that has been developed in Scylla that allows us to scale per CPU. And basically what Scylla is doing, it's like a mini operating system that bypasses a lot of the operating system and is doing its own I/O scheduling, it's managing its own cache. We don't use the Linux page cache, and it has no locks, and basically it utilizes every core individually. And this allows us to scale linearly across cores. So you can just add more and more cores, and Scylla just becomes faster and faster and faster. It's a very unique architecture. I highly recommend that you read about Scylla and our shard per core architecture. Because Scylla is open source, there's actually more projects that have been using Scylla to their benefit, and it's very interesting how this kind of technology enables a new generation of high performance applications, databases. Scylla is also very operator friendly. It's boring. What do I mean by boring? No one likes a surprise in the middle of the night. Surprise. I personally have been running databases for a few years, and it wasn't fun, when a database surprises you in the middle of the night and things crash and you don't know why, and it's horrible. Scylla is auto-tuning. You don't need a lot of configuration. Scylla kind of finds the right configurations for you. It's also, we gave some talks and webinars about this. It's a really cool technology that we're using. So you don't need to figure out how much RAM you need. You don't need to figure out what the right level of parallelization is, and how much memory you need to give the cache and stuff like that. We actually do all that for you, because usually the database, it can actually see the workload, and it can actually know better than you do most of the time, what to do. So you just tell it in general terms what to do, and it does it for you. It's also very resilient. So not a lot of crashes. You don't need to wake up in the middle of the night, which is great, because we all want to sleep. Scylla is also universal. What does it mean, universal? It means that we support multiple APIs. We support Cassandra compatible SQL API. So you can use Cassandra drivers if you want. We also have our own drivers, which are more optimized, but you can use Cassandra drivers. It works. It's full compatible. You can also use the DynamoDB API. We have a project alternator, which allows you to use the DynamoDB API with Scylla, which also means that you can run a DynamoDB compatible database off the cloud, which is kind of amazing if you think about it. Scylla can run in the cloud. It can also run off the cloud, on premises, and also it supports Kubernetes. We have a Scylla operator, which is a Kubernetes operator, which allows you to run Scylla on top of Kubernetes natively. So check it out. It's really, really cool. And it's all open source. The Scylla is a database that has been originally written by the same team that built KVM, which is a hypervisor that's basically powering all the clouds today. And the core of the company is actually people who worked on Linux kernel, on MySQL, on JVM, so a lot of open source projects. So open source is in our in our culture, very deep in our culture. So almost everything we do is open source. You can check it out in our GitHub repositories. Sister is open source, Scylla is open source, a lot of other projects that we do. It all has comprehensive documentation. We really invest in documentation. We also have something that's called Scylla University to help people learn how to use Scylla and related technologies in a more structured and fun way. We also have a community that usually meets in Slack. Check it out. So you can get a lot of help there if you decide to use Scylla or check it out. So check our community. A lot of people are present in Slack and happy to help. And also, this is something that actually runs in production. This is not science fiction. It runs in production. A lot of companies use it in high scale. So we get a lot of really cool feedback, and we keep developing and improving the product. So if you want to use Scylla, you have two options. You can download Scylla. You can download it from a website. You can install it, run it yourself, or you can use the managed Scylla database as a service, Scylla Cloud. You don't have to run it yourself. You can just log into Scylla Cloud and just boot a cluster right now. We give you a free cluster for 24 hours to test. We also have something called the test run, which boots up the cluster for you and runs automatically a load test on it, so you can actually see the results. You don't have to take our word for it. You don't need to believe me that the Scylla is fast. Just go run the test run and see for yourself how fast it can be. Scylla Cloud is fully managed. You don't have to manage the servers yourself, but you can also use Scylla Cloud with your own AWS account. So if you get some kind of a discount from Amazon or whatever, or you want things to run in your own VPC on servers that you own, we also support that. You can bring your own account, and Scylla Cloud will manage the Scylla clusters for you. So this is a bunch of logos of some of our users. As you can see, a lot of really big companies that are running scale use Scylla. We are adding more and more every day. If you want to join, you can talk to me after, or just talk to directly to ourselves, or just run clusters on Scylla Cloud. I'm going to be here in Discord all day to answer questions. We're also recruiting people if you're interested in a job as in engineering or otherwise. So you can catch me in Discord to talk about performance, jobs, distributed systems, or the cloud, or whatever else you want to talk about. So thank you very much.
Thank you, Avishai, for this lovely presentation of what Scylla does. I'm sure everyone will go visit you on your Slack and on the Discord.